All right, so let's do that thing that we do, which is math. Okay, and I'm showing you the answers already. That's okay. So first question, which of the following sequence of transformations maintains congruence of a figure? So remember, congruent, the only one that is not congruent is going to be dilation. Okay, so dilation equals not congruent. So if we're looking for the ones that maintain congruence, which means stays congruent, we don't want dilation. So this has dilation, we don't want it. This one says rotation and reflection, so that's good. This is a translation followed by dilation, we don't want it. A dilation, we don't want it. Okay? So our answer choice here is B. Oopsies. Okay, which of the following are rational? Okay, so 1/4 fractions are rational. Okay, I don't know the square root of 8 off the top of my head, so that one is not rational. -3, positive and negative numbers are rational. Pi is not rational. I do not know the square root of 11, so not rational. And 5/6 is a fraction, so that is rational. So A, C, and F. I'm left-handed, so also my my check marks are correct to me. They're not correct to people who are right-handed. Okay, so find the difference. Difference means subtract. Okay, so we have 9 times 10 to the 5th power. So 9 times 10 to the 5th power, 1, 2, 3, 4, and 5. 4 times 10 to the 3rd power, 1, 2, and 3, and we got to put our 4 here. Okay, and we are subtracting 0, 0, 0. We're going to have to borrow here because we cannot take 4 from 0. So we'll borrow. This becomes an 8. This was a 10, but we have to borrow, so now it's a 9, and this one is a 10. 10 minus 4 gives us 6. 9 minus 0 is 9, and 8 minus 0 is 8. It wants it in scientific notation, though, so we are going to start at the back of the number and move that decimal over 1, 2, 3, 4, and 5 times. So it'll be 8 and 96 hundredths times 10 to the 5th. That's where that 5 comes into play there. You want to make sure that you move your decimal all the way over until there's just one number to the left of the decimal. Place each number where it belongs on the number line. Okay, the square root of 9 is in between the square root of, the square root of 9 is 3. It's not in between anything. The square root of 9 equals 3. So we are going to put this at 3. Okay, the square root of 16 is at 0.4. I don't know why I did that on top of it. So 0.4 is just to the left of a half. 0.5 is a half. So the square root of 5. So the square root of 4 we know is 2. So the square root of 5 is just over 2. And the square root of 23 is just under the square root of 25, which is 5. So it's going to be just under 5. Okay? All right, which graph shows a linear function with a decreasing rate, constant rate of change? Okay, so a decreasing slope, because a slope is another word for constant rate of change. Okay, and that is going down. Decreasing means down. Okay, so A is pointing down. Remember when we read in In America, we read from left to right. So we are going to read the graph the same way, from left to right. So if I'm starting on the left and I'm moving to the right and it's going down, that is decreasing. Okay. All right, 95 7th and 8th graders were asked if they prefer PE or art as an elective. Complete the frequency table below. So a total of 95. And now that we have 4 numbers on our chart, we can finish the rest. So I'm going to subtract 95 minus 43 to get that number in the middle. So that's 52. And then we can do 43 minus 18 to give us this last number. So 43. We're going to have to borrow here. Remember, you can't use a calculator on this section. So you're going to have to just do it the old-fashioned way out to the side. Okay, 37 minus 18 will give us this middle number. Again, you're going to have to borrow. 17 minus 8 is 9. 2 minus 1 is 1. It's 19. 52 minus 19. That's 33. And then we add here going this way, or we could subtract 95 minus 37. So, but if we're adding, that's going to be 58. Okay, and then the answer, or the second part of this question is how many 8th grade students preferred PE as an elective? So how many 8th graders prefer PE? And that is 33. In order to get this question right, you have to have every part of this question correct. So you have to have all of these numbers have to be right, and the part B has to be right. But just make sure that you're adding and subtracting carefully. Really, that's all this problem is adding and subtracting. So it's really not hard. We just have to do it carefully because there's a lot of room, because there's a lot of numbers that we're filling in. There's a lot of room for error here, but like careless mistakes, but it's easy stuff. So you just need to take your time, go slow with it, and maybe go back and check it over. Do it again once or twice because you guys have plenty of time on this. I would suggest going back and doing something like this a couple of times because this is going to be one of those 3-point questions, okay? And the 3-point questions are the most, right? So we want as many of those as we can. So you have to get it all right, though, in order to get those 3 points. Which of the following is not, this is one of those key words, not equivalent to 4 to the 5th power times 4 to the negative 11? When we are multiplying exponents with the same base, we add our exponents. So 5 plus negative 11 actually gives us negative 6. So 4 to the negative 6th power is equal to it. If we wanted this to be a positive exponent, we could flip it over the fraction bar, so it would be 1 over 4 to the 6th. And then we could actually do that. 1 over 4 times 4 times 4 times 4 times 4 times 4. Sorry, I got cut off there a little bit. So 4 times 4 is 16, 4 times 4 is 16, and 4 times 4 is 16. And we're just multiplying these together. 16 times 16 is 256. If you didn't know that, you could do that off to the side. We can't use a calculator here, so now we have to do 256 times 16. 6 times 6 is 36. 5 times 6 is 30, plus 3 is 33. 6 times 2 is 12, plus 3 is 15. 0 to hold our place. 1 times 6 is 6. 1 times 5 is 5. And 1 times 2 is 2. And then we add those together. We have 6, 9, 10, and 4. So that is 1 over 4,096. So this is equal, and this is equal. And really this is equal. So to this. So we want the one that is not, though. The question said which is not equivalent. So A is equivalent. B is not equivalent, so that one's right. C is equivalent, and D is equivalent. So our answer choice here is B. There are approximately 91,440 millimeters in a football field. Express this number in scientific notation. So when we are expressing a number in scientific notation, we've gone over this in a previous problem, we just start at the back of the number and we want to move that decimal point until there's just one number to the left of the decimal. So 1, 2, 3, and 4. Okay, and so our answer is going to be 9 and 144 thousandths times 10 to the, we moved it 1, 2, 3, and 4 times, so times 10 to the 4th. Okay, which of the following equations could not be which of the following could not be values of A and B in the following equation? So we remember when we are when we are multiplying exponents with the same base, we add our exponents. So A plus B has to equal -8. Okay, so A plus B equals -8. So we want to see which one does not equal -8. Well, -4 plus -4 equals -8. So that does equal, so that's not our answer. 4 plus -12 also equals -8. -3 plus -5 also equals -8. And 10 plus -2 equals +8. So our answer choice here is D. Oops. Okay, complete the table representing a relation that is not a function. Not a function. Okay? This could be a bunch of different answers, but here's what we need to make sure of. Okay? We need to have more than one of the same x value for the y values. Okay? So if we've got 1, 2, 1, 3, and 2, 4, that is not a function, okay, because we have 2 of our x values over here, okay? So here is another example of that. For every y value, there is more than one x value. So for every y value, there is more than one x value, okay? So as long as yours had that, then it would be correct. It doesn't have to be these same exact numbers. Okay, determine if the following are rational or irrational. I do not know the square root of 18, so that is irrational. 3/4 is a fraction, so that's rational. The square root of 121 is 11, so sorry, that is rational. And -13 is rational. Okay. Which of the following are not linear functions? Again, these key words. Select all that apply. That means more than one answer, but less than all of them. Okay? This is a linear function, A is, so that's not it. Remember, if it's in y equals mx plus b form, okay, then it is a linear function. Okay? B is not because x is squared. Okay? Okay? X is equal to 7. We can't have that. So that is not a linear function. We cannot divide by x here. So that is not a linear function. And this is in y equals mx plus b form. So it is a linear function. So our answer choices that are not linear functions are B, C, and D. Roxy's Boat Rentals rents paddle boats for a total cost C as shown in the table. Okay, so write an equation that represents the function. So we're going to start by finding the change in y. So 22 to 34, we are adding 12. 34 to 46, adding 12. And 46 to 58, add 12. We are adding 1 over here on this side. Put your change in y over your change in x. And then put that next to x and see if it equals y. Well, 12 divided by 1 is 12. So we'll put 12 next to x and see if it gives us our y. So 1 times 12, does that equal 22? No, it does not. So we need to add something to this in order to make it 22. Well, 1 times 12 is 12, and 12 plus 10 gives me 22. So we're going to add 10 here. Okay, but remember we are replacing our y with c. So C equals, and we are replacing X with H. So 12H plus 10. Okay, what is the rate of change? Another word for rate of change is slope, and our slope here is 12. It's the number in front of X. That is your slope. Okay, and then our initial value, another word for that is y-intercept. So that is our 10. Okay, the mass of an average mature silkworm is about 3 times 10 to the negative first grams. The mass of an average adult female Asian elephant is 3 times 10 to the third grams. About how many times greater is the mass of the average female Asian elephant than the average mature silkworm? It's a mouthful. Okay, so we have 3 times 10 to the third, and we want to figure out how many times greater this is than 3 times 10 to the negative first. Okay, so 3 divided by 3 is 1. Okay, and then we've got to move, not move. When we are dividing exponents with the same base, we want to subtract our exponents. So 10 to the third minus negative 1. Okay, when we subtract a negative, it's the same thing as adding. Think about that if we're adding, I think with my kids talking about sandbags and balloons, and sandbags are like negatives, and if you add sandbags it goes down, but if you take out the sandbags it goes up. Anyways, but subtracting a negative means the same thing as adding. So here we've got 3 minus negative 1, which is the same as 3 plus 1. And that is 10 to the fourth power. So 1 times 10 to the fourth power. So 1, 2, 3, and 4. So 10,000. Okay. Oh. Which of the following sequences does not maintain congruency? Does not maintain congruency. So when it says does not maintain congruency, we are looking for the word dilation. Not congruent is dilation. Okay, so this does not have dilation. This one does. This does not have dilation, and this does not have dilation. So the only one we are looking for is B. Name all of the triangles that show the slope is the same everywhere along the line. So what we're looking for is these right angles. Maybe red. Okay. Okay, and if it doesn't have a right angle, like this is not a right angle and this is not a right angle, we are not talking about those. Okay, so my triangles are A, B, C, C, F, G, and J, K, L. Your middle of your angle is always going to be the middle letter in your, when you're writing it. Okay, evaluate, express your answer in scientific notation. So we have 7 times 10 to the 9th power. Minus 3 times 10 to the 9th power. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Sorry, I did that very sloppily, which if we are subtracting, you need to be really careful about this because we want to make sure that we are subtracting correctly, okay? But what I do notice is that both of these are to the 9th power, which times 10 to the 9th power, which means they both have the same number of zeros, which is 9. So our answer is just going to be 7 minus 3, which is 4. Oops. 7 minus 3, which is 4. And then 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so 4 times 10 to the 9th divided by 2 times 10 to the third power. So we keep this on the bottom still. And then now we are going to divide the first two numbers and then subtract our exponents here. So 4 divided by 2 is 2. And then 9 minus 3 is times 10 to the 6th power. And it said express your answer in scientific notation, so we are going to leave it like that. 2 times 10 to the 6th power. Which of the following could be the side lengths of a right triangle? Okay, so for this one, we need to find a squared plus b squared equals c squared. So what I'm going to do is square each one of these and then see which ones I can add together in order to equal the third one. So 5 squared is going to give me 25. 9 squared is 81. 12 squared is 144. 13 squared is 169, I think. Let's just double check that. Yes, 169. I was right. Okay, and then I think this is 196, but we'll double check. 4. Is that right? 15, that's 556. I knew it was 196. But this is why it's good. We always check our work and work out our problems on paper, because sometimes it just helps verify that our answers or what we're thinking about in our head is correct. Okay? So, teachable moment. All right. I'm going to erase this, though, so we have more room here. Okay. So now we want to add 2 of these up to get a third. So 25 plus 81 is not going to give us any of these others. 81 plus 144 is not going to give us one of those. Too big. But 144 and 25, let's see if that does. Yep. Okay, so 25, 144, and 169. Okay, when we add up our a squared plus our b squared, it has to equal our c squared. Our c squared is always going to be our biggest number out of the 3. Okay, what is 0.27 written as a fraction? Another way to read this number instead of just 0.27 is actually 27 hundredths. Okay, so when we write it as a fraction, we write it just as we read it. So whatever place value this number is in, the last number, that is what number it goes over. So if it's in the hundredths place, we put it over 100. If it was in the tenths place, we would put that number over 10. Okay, so if it was in the thousands place, this is the thousands place, we would put that number over 1,000. Okay, so we are reading it by place value, and then we are writing it as a fraction the way we read it, whatever place value that's written in. Okay, so solve for y. Y to the third power is the same thing as y times y times y. These all have to be the same number, equals 0.125. I'm going to forget about the decimal for now, and I'm just going to think about y times y times y equals 125. Okay, so let's forget the decimal. We'll add in our decimal later. We need to think about what 3 numbers, the same number, when multiplied by itself, gets us 125. Okay, you can kind of guess and check your work along with this problem. So let's, for instance, let's say you do, let's say you can start with 2. 2 times 2 times 2, just to see what it is. 2 times 2 is 4, and 4 times 2 is 8. That's way off, okay? So then you can go maybe in the opposite direction and do 9 times 9 times 9. 9 times 9 is 81. Oopsies. And 81 times 9 is going to give you a number that is way bigger than this. It's actually 729. So that's not going to work either, okay? So it's probably in the middle of these, and so I would go with 5. 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 happens to be 125. So our answer is 5. We are not done, because remember, we forgot about our decimal. Okay, we have to go back and put that decimal in there. Okay.